If you work in the construction industry, you know that concrete is a widely used construction material. What you might not know is that in fact, concrete is the most used construction material in Australia and globally. Mainly because of the large quantity of concrete that we use to build our buildings and infrastructure, a significant portion of embodied carbon of our building and infrastructure relates to concrete. That's why reducing the embodied carbon of concrete is a key focus for the construction material industry and especially for us at Boral. Now, if we have a close look at what concrete is made of, we realize that there is one key component in concrete that contributes the most to the embodied carbon of concrete. This component is cement, which is also the key binder for concrete. In fact, in a typical concrete mix, more than 90% of embodied carbon of concrete comes from cement. Now, with this in mind, there are two key pathways to achieve significant reductions in embodied carbon of concrete. The first pathway involves reducing the emissions at source, which includes decarbonizing cement and concrete manufacturing process. The second pathway involves reducing the amount of cement that we use to make concrete by trying to replace cement at least partly with alternative lower carbon materials. Reducing the emissions at source by decarbonizing our cement and concrete manufacturing operations is the key focus for Boral, and we have the ambition to achieve net zero by 2050. We are investing significantly on projects to help reduce our Scope 1 and Scope 2 emissions. For example, we've achieved significant progress in transitioning our key source of fuel from coal to alternative fuel sources. Only in the last 6 years, we've been able to successfully transition from approximately 100% coal usage to providing roughly 30% of the thermal energy used by our kiln from alternative low-carbon fuel sources. We are also investing significantly on projects to reduce our process emissions. This includes our kiln feed optimization project, which focuses on partially replacing limestone, the key raw material used in cement manufacturing and the key source of process emissions in cement manufacturing, with alternative materials that result in no or less process emissions. Additionally, we are also exploring carbon capture, utilization and storage by focusing on a unique technology based on recarbonation process. To improve our technical capability in this space, we are in the commissioning stage of a carbon capture and utilization pilot plant based on recarbonation at our Berrima cement manufacturing site. Recarbonation is a well recognized process and is estimated that approximately between 20% to 50% of process emissions during manufacturing of cement can be reabsorbed by concrete throughout its service life. These are just examples of projects designed to help our decarbonization objectives, and we are making good progress towards our net zero ambition. In particular, in the last 5 years, we've been able to reduce our Scope 1 and Scope 2 emissions by approximately 14%. So we are making good progress in decarbonizing our cement and concrete manufacturing operations. But it should be noted that cement manufacturing is a hard-to-abate sector where more than 60% of Scope 1 emissions are hard-to-abate process emissions. So achieving full decarbonization of cement manufacturing is challenging, and it's going to take a while. So the question is there anything else that we can do meanwhile to achieve significant reductions in the embodied carbon immediately? So this takes us to the second pathway, which rather than focusing on reducing the emissions during operations, focuses on reducing the amount of cement used in concrete by replacing cement at least partly with alternative lower carbon materials. This has been leveraged for years to reduce the amount of cement used in concrete by replacing cement at least partly with so-called supplementary cementitious materials such as slag and fly ash. This strategy of replacing cement partly with supplementary cementitious materials is the key principle behind lower carbon concrete products. However, there is a challenge to be addressed here. The challenge is supplementary cementitious materials such as slag and fly ash do not react at the same rate as cement. This means that as we decrease the amount of cement that we use in concrete and increase the amount of supplementary cementitious materials, the concrete is going to take longer to gain strength. In other words, the early age strength development of concrete would be negatively affected. This slower strength development rate is okay for some applications, but in many other applications, this is going to negatively impact the productivity of the construction process. As a leading construction material supplier, we find this unacceptable, as we believe our customers should not have to choose between decarbonization, performance, and productivity. So the challenge is, how can we design an ideal concrete product that offers significant reductions in the embodied carbon, but do that without compromising the quality and early age strength development of concrete? This is the challenge that we took on years ago, and that's how our Envisia product was born. Envisia is a unique lower carbon concrete product that offers more than 50% reduction in the cement content of concrete. But more importantly, it does that not only without compromising the early age strength of concrete, but also by offering improvements in several key durability properties of concrete. For example, Envisia has excellent resistance to chloride ingress and significantly lower drying shrinkage than normal concrete. The key ingredient making this possible is our patented activator ZEP technology, which among other things improve the early age reaction rate of the binder system. Additionally, Envisia is a well-proven concrete product which has a successful track record of application in many major projects. Envisia can be used today to reduce the embodied carbon of building and infrastructures, and can be used to do that with no compromises. A key concern about lower carbon concrete products is whether we can continue to supply these products in the long term. This is particularly a concern due to the anticipated shortage of slag and fly ash in the future, especially given the expected closure of coal-fired power stations and decarbonization of the steel industry. At Boral, we have a clear plan to address this potential risk, and we are investing significantly on research and development to develop products using alternative supplementary cementitious materials, which include recovered fly ash and calcined clay, to name a few. In particular, over a 3-year project with University of Technology Sydney, we have demonstrated that calcined clay could be a suitable replacement for slag and fly ash, and we are now working on developing the next generation of lower carbon concrete products using calcined clay. So, we have a clear plan and a range of products to help you decarbonize your building and infrastructure projects. And more importantly, do that with no compromises. So I'd like to invite you to reach out to our dedicated technical and sales team to learn more about how our lower carbon concrete products, including our unique Envisia product, can help decarbonize your building and infrastructure projects.